In this second part, we unpack the biotic pump, the small water cycle restoration, and how he discovered syntropic agroforestry, which gave him hope again that agriculture could be part of the solution. We also covered the latest in gene and genome research and other massive surprises in science lately. For example, the selfish gene turns out to be not so selfish. And why he's excited about a lot of the new technologies, but why we have to be incredibly humble. And of course, how would Antonio invest $1 billion? And why money is like fireworks. This is the Investing in Regenerative Agriculture and Food podcast, Investing as if the planet mattered, where we talk to the pioneers in the regenerative food and agriculture space to learn more on how to put our money to work to regenerate soil, people, local communities, and ecosystems while making an appropriate and fair return. Why my focus on soil and regeneration? Because so many of the pressing issues we face today have their roots in how we treat our land and our sea, grow our food, what we eat, where and consume. And it's time that we as investors, big and small, and consumers start paying much more attention to the dirt/soil underneath our feet. To make it easy for fans to support our work, we launched our membership community, and so many of you have joined us as a member. Thank you. If our work created value for you, and if you have the means, and only if you have the means, consider joining us. Find out more on gumroad.com/investing-in-regen-ag. That is gumroad.com/investing-in-regen-ag. Or find the link below. Is that something you would do? Like, in terms of, not to take away this train of thought, but I'm always curious. That's why we asked, and then I have another question on how we get this level of awareness into people without shooting everybody to space, which would be a nice solution, but in the medium term, maybe not so workable. But let's take you a bit unpractical, but let's go there in a second. One question I want to ask before, which we usually call the $1 billion question or €1 billion question. If you would be in charge of a significant, like it's a lot of money, and at the same time, compared to some other people, it's nothing. But let's say you had this amount of money to put to work, and I'm not looking for exact amounts, but I'm looking, what would you prioritize? What would be a few things you would really say, okay, with a big bucket of money, you could do, if invested, you could do you could kickstart, as you say. What would you focus on if tomorrow morning you woke up and suddenly you had this kind of money to put to work?
I would fund unicorns, natural unicorns. Unicorns is the term used for those folks who are creative and they invent new software, new hardware, new stuff, especially in the information age, in the information frontier. I would stimulate the emergence of unicorns in regenerative agriculture. Why? Because if I put 1 billion these days is really nothing. It's a very small amount of money. Just think about how much money was spent in the Ukraine war in the last 2 years. So 1 billion is floating around. I've heard from colleagues operating in the financial world that they say there is too much money to lead too few good projects. But this too few good projects is because the people in economics, they are not aware of what is brewing into this so-called alternative agriculture, alternative ecology, etc., etc.
Forestry,
and they have
alternative investment.
And they have discarded it. Basically, you say, "Oh, those guys are dreamers. They don't have the foot on the ground."
They're the hippies.
Yeah, exactly. They're hippies, and what we see is that everything in nature that has a global reach has in it the exponential function. Exponential is the math of explosion. And you see if you look what the marvels of what the Chinese economy is doing, in the last several years, it's like decades. It's basically dealing with exponentials. Thousands of years ago, the Chinese built the Great Wall, right, to protect them from invaders, and they built 12,000 kilometers of walls, stone walls, without having the machines we have today. And they did this because they applied something that the labor and the exponentials. Now, with the comeback of the Chinese civilization, you see they applying similar things. They have developed the fast train network in China. In 20 years, they built 35,000 kilometers of bullet trains in China. And they're doing this with solar panels, with electric vehicles, with everything, you name it. And I think this is a very good recipe, that you invest your money to obtain a result, not only to obtain profit. Because when you only look for profits, and you can get profit, for example, from fluctuation of values, which is not necessarily something that is healthy for the planet. You can make a lot of money in the stock market, but just because the prices fluctuated due to all sorts of irrelevant factors.
In the best case, you're not doing any harm, but in the worst case, you're probably causing some harm somewhere.
Yeah,
you're definitely doing there are no benefits.
There are no benefits, and right now we need desperately investment in natural in systems that respect the technological superiority of nature, that realize that Gaia is well ahead of us. So when many people in the technological and investment-minded world, they think that nature is going back. It's like going to a primitive state, which is nothing can be farther from the truth. Going back.
How do we make them see that? I'm not saying it's to see them, but how do we
overview effect?
The group of Chinese in charge.
Overview effect. Even the Chinese need to learn some of this, because, for example, the Chinese have invested for decades now, almost 3 decades, in greening. They have the Great Green Wall in China. But they have met limited success. A study published in 2017 showed that only 15% of the trees planted by the Chinese over the previous 25 years actually formed a canopy.
Friends of the podcast, Laura Ortiz Montemayor is co-organizing LARIS, the Latin American Regenerative Investment Summit, from the 12th to the 14th of March 2025 in Bogota, Colombia. Pioneering event focused on regenerative investments in Latin America. Investors, financial institutions, entrepreneurs, farmers, business leaders, NGOs, academic experts, governments, and policymakers will meet. Find out more on regenerativo.org/LARIS or find the link below.
Why? Because
1.5 we're talking here. 15%. Yeah.
It's a minor. It was an incredibly waste of energy, resources, etc. Why? Because the Chinese do not know about the biotic pump. So if you go inland near the Gobi Desert and you plant zillions of trees, and you don't take care of them, if you don't water them, etc., they die off. This has happened, for example, in China is one case, but you have, for example, in Senegal, they have planted billions of trees with money from the UN, etc. And 8 years later, you go back there, and many of those trees were harvested for fuel wood. People didn't have fuel to cook. So they harvested the trees that were planted to restore the ecosystem. And so in China, they didn't know about the biotic pump. You need to have a conveyor belt built from the shores inland. You have to understand the circulation, the atmospheric circulation, and you have to plant trees.
So just for people that are now blanking and like, what is he talking about? Biotic pump? Like, just to walk us through the science there and the dynamics of how you would do that differently with way more success if you took into consideration what we know now about the biotic pump, about flying rivers, about how water moves in small and larger water cycles. Just for people to repeat. We've talked about it a lot on the podcast, but I can't assume everybody knows. So let's unpack that a bit.
Yeah. Well, first, for most of Earth's life, there was no vegetation covering the lands. So the lands were basically barren. And then life evolved out of the sea, climbed on land, and colonized the land. It took millions, hundreds of millions of years for them to invent plants, to invent trees, and eventually producing forests and covering the land. And for a good part, until, say, 12,000 years ago, when the Holocene era was starting, Earth was covered with forests. The Egyptians, they crossed the Red Sea to log big trees in Saudi Arabia. You go into caves near Riyadh in Saudi Arabia, and you see rock paintings showing giraffes and palm trees and elephants, etc. It was green. Sahara was green. Australia was green.
Not that long ago.
Not that long ago, 12,000 years ago. And more and more studies are showing that basically raising animals, browsing animals, was the main source of deforestation and desertification for most of those areas. And we are now documenting it happening in South America. The Amazon as we speak, is being transformed into a desert by the forces that in the past they didn't have tractors, they didn't have chemicals, they didn't have genetic manipulation.
So it took a bit longer, but now we're fast.
Yeah, we are doing it exponentially, and it's very hard to convince those guys with the mentality of the Green Revolution that what they are doing is shooting their own food, because as you deforest, you lose this biotic pump, and then you lose the flying rivers, and then you lose the importation of moisture inland. Nature took millions of years to colonize bit by bit, from the seashores inland and greening the continent. And now this system works in it's very complex, but it is not too complicated to explain. You have
luckily
trees which have deep roots. They pump water from the water table inside the soil out through the trees and through the canopy and into the atmosphere. In the tropical zone, you have a lot of heat, so there's a lot of evaporation. Evaporation cools the surface, which is incredibly important for the trees themselves and for creating a very favorable environment for life in general, inclusive for agriculture in the surrounding areas. And this vapor, as it rises into the atmosphere, when it gets to about 4 or 5 kilometers, it meets small condensation seeds that are particulate material produced by the forest itself, spores, pollen grains, and also chemicals that released by the plants. And those.
But this is an important piece. This is those particles come from the forest.
It comes from the forest itself.
Just for people to remember.
But they are
not from somewhere else. They come from a healthy forest.
Yes. and they're invisible. So that's why I call the fairy dust, or pixie dust, because there is a dust that is produced by the life itself, a highly sophisticated mechanism through which the forests make the water vapor in the air condense and produce clouds. Those clouds are very healthy clouds. They are white. They reflect a lot of the sunshine, incoming sunshine. So they cool down the tropical area, and they produce rainfall, plentiful rainfall. Because they are low, they don't produce a lot of ice inside. Basically water, liquid water, and so they're abundant liquid water, which keeps the forest going and thriving. When this water vapor that's in the air condensates, it disappears from the volume. It produces droplets, and then you don't have the water vapor gas anymore. So it lowers pressure and produces a suction. Lowering pressure on land, it's conveyed to the sea nearby and pulled moist air from the sea inland, and then driving the hydrological cycle on land. And without this, you have the opposite. The air, dry air over land, because land is desert. It flows from land to the sea, not allowing moist air to come from the sea inland. After all, the seas have 97% of all water on the surface of the planet. And so even though the sea has salt water, when it evaporates due to sunshine, you have fresh water. The clouds over the oceans are made of fresh water. And as they move inland, due to the biotic pump, to the vegetation effect, then they bring fresh water inland. And this is what drives everything. Everything is driven, agriculture, industry, the rivers, the ecosystems, everything thrive on fresh water coming from the sea due to the biotic pump. So this is the short explanation for this.
And I think we cannot repeat it enough how fundamental healthy vegetation is in pulling or in triggering or bringing in moisture from the sea. Without that, the sea would still evaporate. And we've seen that actually in the Mediterranean this summer. The sea would still evaporate because it's still warmer and warmer, but this moisture doesn't go anywhere until it's being hit by, in this case, I think it moved. We remember the floods in Central Europe at the end of the summer. Like this evaporation still needs to go somewhere at some point, probably with quite destructive force. But if there's healthy vegetation, like if there would be healthy vegetation from the Gobi Desert to the sea, a lot of that moisture would be drawn into piece by piece, not in one shot, but piece by piece to wherever I'm not saying we're guiding it, but wherever it flies to. But you need that vegetation to also evaporate. Yeah. It's not like we always remember this water cycle. Okay, there's evaporation, the wind blows it on top of the land, and then it rains. Yeah. Now that's fundamentally wrong. Without the land being healthy vegetated, it won't rain. It won't bring in the moisture from the sea.
It is fundamentally wrong for many reasons, not for just one. Because first of all, the wind doesn't blow the moisture from the ocean on land.
Because there's no suction.
Except for a few places on the planet. But because the wind blows from land to sea when you have a desert. Right? That's what you see. You get a continent-size piece of land like Australia, and most of it is barren because exactly of this. And you see this. There is a beautiful animation done by NASA showing in 3D the clouds forming all around Australia, and only the eastern border has a little bit. And you have, of course, rainforest there in Queensland. And in other places, you have a little bit of wind that comes to the edge, but that's it. And the rest is basically the opposite. And for example, in the lowest plateau, in the central part of China, they have obtained a miracle there, because they have been able to, first of all, stop the erosion. They took out the browsing animals, especially goats, which were being very detrimental for vegetation in general. And they have invested heavily in greening the area. All documented by our dear colleague John Liu.
Yeah.
And so, but what happened then? It was a confusion, because part of the lowest plateau was getting more rain. Actually, it seems that most of it was getting more rain, and nonetheless, there was a lowering of the water table, and the rivers started drying up. And that's remits us to what Anastasia was saying, that if you put a lot of trees far inland, and trees are pumping moisture from the soil up into the air, and the wind is blowing the wrong direction, so to speak, between commas, in the wrong direction, then you lose that water vapor, because it goes into the Gobi Desert instead of, and it doesn't pull anything in the back. Now, if we, instead of doing this greening effort far inland, detached from the shores and far away from the sea, we did that progressively from the sea inland.
That's how you would do it. You would start at the sea,
exactly.
And start like as life did it in the past, like step by step, meter by meter,
and eventually you restore the biotic pump. I think Ernest Goetsch, who is this farm in southern Bahia in Brazil, he did exactly that. He's very near the ocean. And he restored.
Yeah, I was going to ask, how far is he from?
He's about 30 kilometers. 30 kilometers. Yeah. There are other small vegetation pockets here and there. And he reestablished the Atlantic forest in a patch of land of I think it was like 500 hectares. And during the peak of dry season, not dry season, actual droughts, episodic droughts, his farm was the only one that was green there. Like Frozen, the movie from Pixar.
We're really looking forward to seeing you all at the Regenerative Food Systems Investment Forum, February 26th, 27th in Brussels. Use Koen 10, that is KOEN 10, for 10% off. Find the link below or search for RFSI Europe. Yeah.
And they have this snowman and this small cloud on the top of his head and snowing.
It's always raining. It's always snowing.
Yeah. And that's what Ernest got in his farm. It's the only place where you have this rainfall more plentiful, and the farms around all basically broken, not productive anymore, and his one is still with streams flowing, etc. So he didn't know about the biotic pump until we met and we started interacting, and we knew little about the syntropic agriculture that he proposed.
How was that, discovering that, or how was it? Do you remember when you first saw that potential or saw that world of syntropy or syntropic agroforestry or syntropic silvopasture?
Well, I didn't have the syntropic agriculture, but I had the rainforest, and so
the extreme version.
The extreme version. And I tend to think that agriculture and a fully functional, plentiful, marvelous ecosystem were incompatible. That we could not combine the two. And that tend to be my view of this until I heard about Ernest, and I met him in a farm in São Paulo in 2015. And he took us to a place where he was recovering that was degraded. And I saw a lot of weeds. You know, for an agronomist, usually weed is a bad thing.
Uh-oh.
Yeah, weed is a bad thing. It's something that you say, oh, this place is infested with weeds, and you start thinking about how to remove those weeds, how to get rid of them. And I asked him, I said, Ernest, how I can see you have tiririca, which is a common weed in São Paulo. So how you deal with tiririca, how you deal with it. And we say bad, how you call that, erva daninha, I don't know how to translate that. Is a damning...
Weed of the devil?
Yeah, like a damning plant or something. He turned to me and said, damning plant? No, miracles plant. And a miraculous plant. And then I got shocked because miraculous plant, what does he mean? And then he explained, he said, look, this plant grows where no one else wants to grow. This is basically telling of its innate capacity to deal and to handle with a degraded soil, degraded environment. And it does it wonderfully. And it produces green mass. That's what we are looking for. And then he developed this machine that it looks like this old thing people use to cut hair. You have I forgot the name. He developed a machine that's very light. It had a shearing stuff that was cutting the weeds ahead of it. And then it was pulling it to the side and making those piles of organic matter from the weeds and in the foot of those trees that you were planting. And there you had, imagine, you had he was using the weeds to gain capital. Weeds were the ones who were converting nothing, carbon dioxide, and degraded soil into something, organic matter. And organic matter in the food of those trees meant many things. Among them, a deterrent to leaf-cutting ants, because leaf-cutting ants in degraded lands can be a problem. If you're planting trees, the leaf-cutting ants come and they destroy all eventually kill the trees, if like fruit trees.
Oh, your solar panels, basically.
Yeah, exactly. It's like you're losing value in your stocks. You have an investment there, and there is someone who's predating it. Go during nighttime and eat all the leaves. But when you have rotting organic matter on the foot of those trees, the leaf-cutting ants like Atta sp, for example, one species, it doesn't like it. It doesn't cross it. So you protect the trees. This is the first effect. Then eventually you have fungi growing out of the soil into this organic matter. And it turns out this fungi is able to extract moisture from the air. They are hygroscopic. They can trap. This was so amazing for me. One day I went to visit in his own farm in Bahia, not this one in São Paulo, but in Bahia. And it was after 2 years of drought. Every cacao plantation in the region was basically grounded, the zero production. And Ernest had this organic cacao immune from witch's broom, which is a very bad disease that hit the cacao. And he said, yes, I lowered the production. Is not as high as it used to be in a wet year. It was like 20% less, but still producing. And everything luxuriant and green. And you have this rainforest, this Atlantic rainforest on top of cacao. And then I asked him about the drought. And then he raised this litter layer and showed the soil. The soil was bone dry. It was like, a powder. It wasn't really soil because it was so dry. And I thought, this is Harry Potter magic. This cannot be, because there is no moisture in the soil, and the trees don't seem to be affected at all. What is happening here? And then he showed me the litter layer, this mattress of roots and mycorrhizae. And he said, you see the fungi here? This fungi is extracting water from the air and feeding the trees. This water is extracting from the air. So this is absolutely revolutionary science. This is unbelievable, because
absolutely,
this is unbelievable.
What did it do to you, like in 2015 or 16, when you stumbled upon this?
You can see there is a book written about syntropic agriculture, not the one by Felipe and Diana, but another one from someone in Brazil, and they asked me to write like a back cover. And I told this experience. And when he told me, agronomist, ecologist. I am an agronomist and an ecologist. And now I am an earth scientist, and I work with holistic system, etc. And I did not know that agriculture was possible on those terms that Ernest was creating. And I was completely, what? So weeds now are miraculous plants that are our allies. And since then, I have collaborated with Ernest and, of course, with Philippe and Diana. And we have been developing these proposals for putting together this incredible competence of knowledge of Gaia, of life, together with how we fix the systems that have wrought havoc, like agricultural systems, and connecting with the water cycle. This is the thing that we bring from Anastasia, and we are connecting the water cycle, the climate, the understanding of the earth system as a whole, with the actual manipulation through the syntropic. And the thing about the syntropic agriculture, syntropic silviculture, syntropic timber management, or whatever you call it, syntropic, is that whatever you do, invest there, it multiplies exponentially. That's the thing about life. Everything you do, it's true. I mean, you put one seed of corn in the ground, and you have thousands produced in the corn. When you harvest, that's true for nature. This exponential growth, but it's an exponential beneficial growth, not an exponential disease or destructive development.
Parasite.
Yeah, exactly. So this is where I think we struck a jackpot in a conceptual.
Yeah, because the combination of the syntropic side with the water cycle and biotic pump piece seems like a match made in heaven.
Exactly.
Because otherwise you just try to create these little islands of paradise if that even works. If you're too far from the coast, it might not even work because everything between you and the coast is not going to help you. No. But combining that with the water cycle research, the understanding of how that works, the modeling we can do now, like the compute power we can bring to this, and to understand where to go first and how to create these hop island effects of water, seems to be really a jackpot, like you said.
Yeah, and it's like to use nature and nature resources, and what Gaia has invented over, Gaia has dealt with an untold number of cataclysms over 4 billion years. So Gaia has developed incredible technologies to deal with these cataclysms, and it bounced back every time. Every time there was like a big meteor or volcanism or climate change, etc., before humanity, before even animals were on Earth, roaming on Earth, Gaia has invented techniques to deal with this. And there is nothing more simpler and cheaper for us today to resort to than to go back to this technology of Gaia, developed over billions of years. This is the thing about economics, that there is nothing cheaper than to go and take advantage of R&D from nature. R&D from nature is the one that we're not even around when it was developed. And it's there, it's still functioning, it's still there, pumping all these incredible mechanisms intertwined, everything working wonderfully together. Until, of course, we come with a chainsaw. Until, of course, we come with a bomb or with things that, this is a Achilles heel of Gaia. That Gaia doesn't know how to handle chainsaws or big 2 bulldozers with a big chain, destroying 20 hectares of rainforest per hour. Gaia doesn't know how to deal with it, to protect itself from it.
I think we're feeling the result of that. You don't have to look very far. I think as humanity, we're starting to seriously suffer because of that. It's not a direct, like we don't feel it so directly, but we see from health to all kinds. I think we're feeling, let's say, the response of Gaia, of the misuse of all of that. But it's an indirect one, and it's going to hit us. Just probably too late to still fix it. But I don't think we're like a parasite. We'll be strutted off Earth
eventually,
very quickly.
But this imagine that this is horrific.
No, it is.
Many times I see people saying, "We are killing ourselves." Yes, we are killing ourselves. But do we want to do that? To kill ourselves? It's like we have to be able to be sensitive enough to the meaning of whatever we conceive and what we think and what we do. Because imagine, we're crowning, not trying to push the humans as the best, but we are in the top of a process that took billions of years to produce it. It's not out of chance. This is absolutely not out of chance. There is this incredible discoveries every day. If you read the scientific literature, you learn things that are absolutely striking. For example, Professor Denis Noble from Oxford University, he has been a foe to Professor Richard Dawkins, also from Oxford University, because Denis Noble is older than Hawkins, but Richard Dawkins. Richard Dawkins is the author of The Selfish Gene, which in my view is one of the worst possible contribution to human endeavor on
Science
Earth that has ever come about. And recently there was a discussion between Dennis Noble and Richard Dawkins, and I thought it was incredibly interesting because Dennis Noble was basically denying that DNA is the sole and unique source of hereditary in organisms, and basically countering the central dogma of biology, of molecular biology, said by Richard Dawkins. This is his expression, that the DNA system of storing information and then reproducing and allowing organisms to carry on information from generation to generation, the Darwinian thing, is a dogma for them. It's a central dogma of molecular biology. And so Richard Dawkins would have argued with Dennis Noble that if he could get Dennis Noble DNA in a place stored for thousands of years, he could go back, get the Dennis Noble DNA and build another Dennis Noble. And so Dennis Noble responded immediately, said, how would you? Where would you find my mother's egg cell? Because DNA doesn't have genes that define the membranes. You don't have life without membranes. Maybe you have in virus, but it's not really life. Virus is a different kind of information structure. But I mean, anything that has metabolism, like a cell, has membranes. Membranes is absolutely essential. Everything from the outer membrane of the organelles in the mitochondria and the nucleus, etc., everything relies and depends on membranes. And the membrane you don't have from the DNA. Membrane comes from your mother, from the egg cell. Okay, so if you don't have the mother of Dennis Noble, you cannot build another Dennis Noble just from the DNA.
Are you interested in learning more about our Generation Re investment syndicate, where our aim is to make investments into regenerative food and agriculture companies more accessible for everyday investors, with the minimum ticket being 1,000. We've invested in companies across the regen ecosystem, like Wild Farmed, Mad Capital, Rumi, No Fence, Juntos, Collie, Antler Bio, New Foundation Farms, and many more. Find out more on gen-re.land, that is gen-re.land, or in the links below. Which means you cannot see any cell or any gene in isolation.
No,
that's
a gene.
I put a link below.
Yeah, a gene.
I'll put a link below
of
the discussion, but I didn't see it.
A gene is a fantastic thing in terms of gears, like a gear that works wonderfully for codifying the sequence of amino acids to build proteins. But a gene, if you have, as they found it, that very few genes codify directly proteins, like 2% of the genome. And the rest, for a long time, the molecular biologists were calling just garbage. They call it genetic garbage. Of course, now it's changed. They don't call it garbage anymore. They discovered that the genes produces RNA, which is an intermediary, which never produces protein, but they mediate chemistry inside the cell. It's incredibly complicated, incredibly complex, incredibly sophisticated. So even with all our knowledge about DNA and genomes and everything in connection, we should be humble. We know virtually nothing of this complexity. And we are starting to touch the tip of the iceberg on this molecular complexity. Imagine, you need...
How did Richard respond? Like, how did that
Well,
Was
he
it a direct
didn't respond.
conversation?
Watch the discussion. It's really fascinating.
I will watch it.
He didn't respond. What could he respond for this? It's because this is it's coming from the molecular biology field research. It's not something that is uttered by a believer somewhere. It's from the molecular biology research itself. And the more you look into the metabolism, for example, initially in the 90s, when the genome project was starting, was full blown, they thought the belief was once the DNA sequence was mapped, everything would be understood. This is a central dogma of biology, right? If you decode the central molecule, macromolecule that codify for everything in life, then problem solved. We will
be done. Yeah.
And then the first disappointment was this: they could map only 2% that was actually codifying for amino acid sequences in proteins, and they called 98% as garbage. Then they said, well, we won't solve this problem just looking into DNA. We have to also look into the proteins. And they start mapping proteins. And they found that because the original dogma was one gene, one protein. Because one gene had the sequence of amino acids to produce one protein. One protein is like a small robot. You know, a protein is like enzyme, and it will mediate this and this reactions in the metabolism, etc., etc. So it was like a linear, univocal connection between genes and proteins. And then
one in, one out, and we're done.
Yeah. And then they started mapping proteins, and they found, well, they had found like 23,000 genes in the DNA mapping. And then they start in last number I saw, it was like 92,000 proteins mapped. So you had many more proteins, and some suggest there is 400,000 proteins, or even counting a million different proteins in the human cell alone. Imagine, inside this 20 micron ball of water with those organelles inside, etc. It's like a industrial complex miniaturized to 20 microns. And this 90 or 100,000 proteins codified by only 23,000 genes, if that is the case, which is not necessarily. So then they start suggesting, then genes cooperate among themselves to codify different proteins. And then there is also a thing called epigenetics, which basically says that the environment is regulating what is happening inside the cell, not only the DNA. And the more you watch these explanations by Dennis Noble, the more you understand that metabolism is much bigger than the central dogma of biology with the DNA. DNA is as important, but it's a minor part of the much more complex story. And then I go back to, not back, but I go forward to native knowledge. And the native knowledge, they have, this is so, for them it's easy. They don't have this anxiety about this complexity. They have reverence for complexity of nature. They have respect. They worship the complexity of nature, because the complexity of nature is where you have the solution for existence and for life. And that's is not a discourse for a religious discourse. It is a scientific discourse. I intend to be a scientific discourse. And you don't have to be a wacko to believe in those things. This is coming out of the best literature in molecular biology, etc. And we are making those connections of this complexity of life with the geophysical functioning of the planet. And that's the part that it's about time we have means to do it. That's where investment comes in. And people who have the ability or the sensitivity to understand what is, as if nature were a bank, it would have been saved already, right? And if we could use you said 1 billion euros, I would say even less than that.
I think we can use a bit more.
Yeah.
There's still more than that available.
Even less. You can get.
Okay, let's start humble.
Yeah, even
humble.
less, 100 million or whatever, and you get some of this knowledge spread out. Multiplying like you're doing with this podcast, and you multiply this so that people get enlightened, and they have this.
Don't worry. I think this episode will cause some enlightenment on listeners.
I hope so. I hope so.
I definitely.
Yeah, think. And this enlightenment will produce the effect that the astronauts experience. This Captain Kirk from the what is the TV series? Captain Kirk.
Star Trek.
Star Trek. Yeah. He went to Jeff Bezos, sent him to the space with this Blue Origin spacecraft, and he came back crying. He was. You can go on YouTube and put there Captain Kirk and going to space. He represented. The adventure, human adventure in the space, in the series, Star Trek, for decades. And he had never been to space. And Jeff Bezos sent him to space only 10 minutes floating in the weightlessness of this trip. And he came back, he was totally emotional, he was crying. And when later he was explaining his experience, he basically mentioned that he felt the deepest grief. He didn't imagine there was this degree of grief as he felt, because he was in space, he looked back to Earth, he saw this orb, the glimmering, bluish green emerald orb floating on nothing, and he looked back to the space and dark desert of death. He saw death in the space, and here life, and there death, and this was overwhelming, and he felt like grief. He felt the deepest grief because we are destroying life. He immediately had this overview effect in a Hollywood scale,
At 10 minutes.
Yeah, in a Hollywood scale, because he's an artist, and he was powerfully touched by the overview effect. And he said, look, we're destroying it. And people have no clue what they're doing. They should go to the space and look like I did. And he felt grief because some people say, oh, you felt happiness. Here is Captain Kirk finally going to space. No, he felt grief.
No.
Yeah, because he realized what is going on. And I am sure the more people, the thing is that we have our life, I don't know if it's the last words, but I would like to coming to a conclusion.
Please take
it.
Please take the last
First of
words
all,
here.
We have all the means. We have the financial means, we have the technological means, we have the knowledge means to change our stay here on Earth. We have this right now. And to make matters easier, we have all this convergence of information in the internet. We have artificial intelligence to help us derive all of this, some things that we can absorb. We can, it's not like drinking water from a fire hose. We don't have to drink water from a fire hose. We can slowly understand and absorb this. And I have been many times mentioning that we need to go forward to the native knowledge, because native knowledge has in it, it has not lost the connection with Gaia, has not lost the connection with the complexity of nature. And they have simple ways, fable, like fairy tale ways of reporting on how do you connect back to nature, how you connect and respect nature and live in harmony. And on top of that, we have now new technology. We have invented new ways that we can tap, like this wood technology, that we don't have to destroy all the forests in the world. We can plant silviculture, syntropic silviculture. We can reform agriculture through regenerative agriculture, through syntropic agriculture. We can do this we can do social engineering, develop a way of dealing with people in the world that we will bring people together through love and not through competition only. Competition has a role, but it should not be the main one. A collaboration is what we need. We have a sinking ship. The way we are dealing with the planet Earth is making it sink. We are destroying the habitability of Earth. And we are learning very fast that organ failure doesn't happen slowly. It's like you have exactly. It is a sudden, abrupt death. It's not something that comes gradually. It is progressing gradually, the threats.
Until you hit
a tipping point. And we are hitting tipping points. When you see, for example, these floods that happen in Spain, in Congo, in southern Brazil, in the US, and in Central Europe, as you mentioned, etc. People say, "Oh, why this is happening now?" It's because the equilibrium of circulation, oceans, forests, and soils got to a point where the self-regulation broke down. I like the idea of people to ask, what is this self-regulation? I said, look, imagine that you have 209 bones in your body. 209 bones. When you have a skeleton without flesh, without muscles, and it doesn't stand only on the bones. It's an unstable equilibrium. When you have flesh and the muscles and your brain, etc., we stand up through feedback, through self-regulation. You are continuously equilibrating. When you walk, you are falling forward, right?
Forward.
Yeah, you're falling forward.
Which is a good metaphor for what we're doing.
Yeah. Following forward. And if you are standing still and someone come and push you from behind, you get a jolt.
Without thinking.
Yeah, your brain will do all what is required, and your muscles and your lungs, etc., for you not to fall crashing down. You start running forward, etc. When the push is too strong, then you overcome the capacity of the human body to standing still. And then you come crashing down. That's what we are doing with Gaia right now. We are giving it a kick that is so powerful with chainsaws and pollutants and everything that we're doing, greenhouse gases, etc., that a system is eventually crashing down. And when it starts crashing,
and we see it and we feel it.
You didn't anticipate that, because if you were watching someone being kicked and the person always recover, you have the illusion that person will never, fall down and crash to the ground. And we, in our group, we have been able to predict this array of the climate in a global scale. because we had this notion of life and self-regulation, which most of the IPCC didn't have. The most climatologists didn't have. They are not life scientists. They are, physical scientists. And they were basically using statistics. So they were watching the behavior of Earth system while the system is still functional. So it's still self-regulated, still equilibrating the abuse. Excess CO2 absorbed by the ocean. Excess winds, the canopy of trees are diffusing that energy. Excess moisture is raining somewhere, and before it's becoming really damaging, and so on. Excess drought is dampened by vegetation that produces moisture, etc. But if you start removing all the regulation mechanisms, like ecosystems, destroying it and polluting the system, then eventually the kick will be too strong and the system comes crashing down. 10 years ago, actually in 2005, I gave an interview to Vejas, a big magazine, a weekly magazine in Brazil. And they were asking, and I said, what was coming. And back then, even my colleagues called me radical. I was radical because I was predicting things to be much faster than they were actually progressing at that time. And then in 2009, I gave an interview to a financial journal in São Paulo. It's called Valor Econômico. And they asked me again how bad was the situation. I said, terrible. We are in the eve of disasters in series,
mass disruption.
Yeah. And then they asked me how many years we have. I said, well, about 5-6 years before the disaster started, in exponential. 2014, there was a massive drought in São Paulo. I wrote a report called The Future Climate of Amazonia, and I did a scientific review, but using language that people can understand, and telling what was coming. And I was basically alone. I authored it alone, this report, and my colleagues thought I was too radical because I was thinking that things would be happening much faster than the mainstream climatology was admitting at that time. 2015, I was invited by the government of Norway to give many talks in Oslo just 2 weeks before the Paris Agreement. And one talk I gave, there was a Minister of Environment from Norway and the delegation that was coming to Paris. And Norway is very active in protecting forests. They've given $1 billion to the Brazilian the Amazon Forest Fund. And I gave my talk mostly on the Amazon. But in the end, I made a connection with the Paris Agreement. And I basically said that from a diplomatic, governmental, political, even, let's say, economic and business perspective, it was a fantastic achievement. It was genius, because in 2009, the COP in Copenhagen was a disaster, right? Failure, complete failure. And so in 2015, complete success from diplomatic perspective. However, I hear but coming. However, I say nature cares about the laws of math, physics, chemistry, biology, geology. It doesn't give a damn about economics or politics or diplomatics.
If you look from the moon, you cannot see the politics.
Yeah,
you cannot
nature
see
doesn't pay attention. And from that perspective, from nature perspective, the Paris Agreement is a failure, complete failure, declared failure. And so the Minister of Environment from Norway, she was distressed. I could see she was not happy, and she basically said, "Antonio, you're not You're not valuing all the effort we put in this. I said, no, I said it at the beginning. I value enormously. Diplomatically, it's a fantastic success, but it doesn't matter for nature. The only thing that matters for nature is the loss of nature. The loss of humans, the social motivations in humans, nature doesn't care. Of course, our motivations produce effects upon nature, but those are the ones that nature cannot protect itself from. So we ended that exchange. Basically, I proposed to her, I said, look, you don't have to trust me. You just pay attention on the scientific literature in the next years. And in 5 years, we sit back down together. And then we'll see whether you give me reason or not. 5 years later was COVID, right? 2020. And COVID basically brought the awareness that we could stop. We could ground our aircraft.
We could do
and of course, lots of people died, like 20 million people. Not too many if you consider the size of humanity, but it basically was the laws on nature. In this case, the biology is a virus, is a particle that you need to enlarge 70,000 times to see it in the microscope, and
grounded the
whole human enterprise on the planet. So why can't we use our best judgment and our best money to invest in things that will basically change our course? China is showing it in a way. US, all the
other places are showing it as well.
Yeah, look, the
I think it's a perfect
artificial intelligence. Look how it's miraculous. The kind of things that are emerging from unicorns in the US and elsewhere. It shows the way. We can do it. We still can do it. That's my last positive message. We still can do it, but we cannot do it forever. There is a phenomenon called death, where beyond that you cannot do, unless of course you are Jesus and you can bring someone back from the death. But I don't think we can bring Earth, Gaia, back from death. And that's what we should avoid. And we don't have forever. Usually people say, oh no, we should do this until 2100. Forget it. If we
have a couple of years.
Yeah, or actually the time has passed already, right? The best time to do what we should have done was like 30 years ago. And the second best time is now. Today is not in 20 years.
And with that, I think it's a perfect way to, we could go on for hours.
Sure.
And we might do that in the future. I think there's a lot else we should get into. But for now, I want to be conscious of your time, even though we're more than 2 hours in. And thank you so much for this wild ride. Maybe not as wild as going into space, but definitely close to that. We've discussed a lot, and I think and hope, I'm pretty sure actually, this will enlighten many people listening to this. So thank you so much for, first of all, the work you do, how you spend your waking hours, and your not waking hours dreaming about space, and for coming on here to share about it. Thank you, Antonio, so much. And hopefully this wasn't the last one.
Thank you, Koen. It's been a pleasure. I hope it won't be the last one on Earth. And we'll be here many years and celebrating the turnaround and the exponential response in the good way for fixing all the
Thank you so much for listening all the way to the end. For the show notes and links we discussed in this episode, check out our website, investinginregenerativeagriculture.com/posts. If you like this episode, why not share it with a friend or give us a rating on Apple Podcasts? That really helps. Thanks again, and see you next time.